what is called coupling. They call it production. Okay, sometimes it's called network. Sometimes it's called even well. Okay, simulator. And that simply means you have one model, which is a reservoir model. Typically, it's used to estimate how much the evolution of recovery factor in the field, evolution of pressure in the field, and it only contains maybe down to the wellbore interface, okay, to the sand face, or can also have, if you have tubing tables, can also include the flow in the wellbore. Okay, but you need to have tubing tables. So this guy here is restricted to this is all in porous media. Okay, let's see, just the porous media. Here we can have the wellbore can be included, wellbore flow can be included. With tubing tables, okay, which we did a short discussion the week before, and basically is computing saturations, pressures, rates that I produce from the wellbore, but usually doesn't include any more than that. Okay, and it's something that is by itself, by nature, is transient. Okay, well, you have this next part, which is it takes care of all the flow that you have to take from the bottom of the well all the way to the separator. Okay, so here you have the flow line plus pipeline plus wellbore flow. Okay, it's typically steady state. Okay, which is that this derivative that you have with respect to time is equal to 0. Okay, and the assumption or the justification that we can use as steady state is that this evolution on the reservoir is so slow that we can simply take at simple slices in each time and we can check how much pressure do we need. Okay, it's like we look at all of these different slices because it's so slow that the transients really don't matter. I can look at each one of these slices in time as a steady state. Okay, and here typically this runs with IPR, that you know, inflow performance relationship, has boundary conditions. On the well. Okay. And as I told you, we typically, now it's becoming more and more common to use coupling. Companies see that really it's not enough just to take this part alone with tubing tables or without tubing tables or with a minimum bottom hole flowing bottom hole pressure, but actually I need to have this part, okay, to see how much that impacts my production profiles. Okay, it's becoming more and more not trendy, but it's becoming more and more accepted that I have to have this coupling between the two. Okay. And some of the challenges we have discussed before, they belong to different departments in the company, different people in the company, different expertise in the company, so it sometimes can be challenging to communicate and to integrate these two models. Okay, they are also made in different software. But just, you know, I think we have done this diagram in the past. Just save it. Okay, so we have, on one side, we have reservoir simulator. And on the other side, we have this production simulator. And remember, be careful with the word production, because production you know, I call the production system to everything from reservoir to wellbore, but production is typically has a discipline, is typically seen as occupied about wellbore flow, flow line flow, pipeline flow, separation, okay, processing facilities. That's what we refer by production. Yeah? And we have some split in between, okay? And at every time step, okay, let's say a time step equal 1, okay, I estimate PR, okay, that can be for pressure in every cell, okay, I can estimate saturation in every cell, okay, you can estimate, what else can I estimate? Sorry, I cannot. Pi? Okay, permeability, yes, relative permeability, right? Yeah, sorry, you're a bit far away, so. And my hearing is not the best. Okay. But, so you need to, at each time step, okay, a way that we say, and this is explicit, okay, this example that we're going to put here, example of explicit strategy. Explicit coupling strategy. Okay, so I have those numbers and I have to transfer to the production simulator, which is steady state. For that particular time, I transfer some information that either I have in my production simulator, I have an analytical model for IPR. Okay, I have made some analysis and I have found, for example, I can use this back pressure model that we have used before, right? QCR, PW, PR squared. Okay, and in this case, I just need to, for example, if I was using that equation, I simply need to update reservoir pressure, right? Because the C and the N really don't change. But if I have, for example, a undersaturated oil, then it will be something like that. Okay, where I have to update the J doesn't have to be updated, usually remains constant. But if I go and become more and more complicated, okay, then I might use, for example, a Vogel. Okay, let's put that here. In which is not so trivial. I have to find a way. Each model has a way to say, how do you update? In this case, I don't have to update just PR, but all this Q max. Okay, and I have to find a way to update that Q max with the property. Or you can simply generate IPRs from the reservoir simulator. So we call it generated. Okay. Simply I go and I do some method to calculate the IPR of the well. Okay, and that method can be you run a multi-rate test. There are different methods. How can I generate this IPR? After that, I go and I use that as an input to my model. Okay, either the analytical IPR or the generated IPR. And what do I need to run the network? Okay, that's something we have learned the week before. To solve the network, if it's operating at let's say fully open choke, okay, simply I don't need anything else. That's the only thing I need, the new IPR, and then from there I can compute rates, right? From there I could compute Q oil, or let's call it simply Q well I, okay, and also maybe PWFI, and I can calculate many other things. But if I'm not in the if I'm not in the fully open choke mode, what do I have to make? If I'm, for example, in the plateau mode, I need to have here also some, let's say, choke opening, right? I need to have, for example, if I have pumps, I need to have the ESP frequency. Okay, what else can I control? Something that I can control, right? If my network, my production system has chokes only, that's the only thing I can change, okay? But if I have, for example, electric submersible pumps, that's what ESP stands for, then I can regulate the frequency on each pump, okay? If, for example, I have gas lift, right? I have gas lift injection on the wells, gas lift rates, okay? And besides that, I also need to have target rates, right? I typically have, because these reservoir guys, they have said you need to have, if possible, I need to get some rates, right? Some target rates that they have indicated that's the best for depletion of the reservoir. And can be something given by well, can be given by field, okay? And remember here, if we have that case that we have a target, okay, then we sometimes need optimization, okay, what we call optimization inside this model. That we have done it with Excel, right? We have said we want to achieve these rates, and then we use Excel to change the delta P of the choke to get exactly that rate. Then in an explicit scheme, simply you send those numbers back to the reservoir simulator, okay? And now the reservoir simulator imposes those rates on the sand phase. It says to each well, now this is the rates that the network says I can produce, okay? And can either be equal to the target rate or it can be different, okay? I bring them back to the reservoir model and I compute the time step T2, okay, PR, SO, SW, SG, and then everything is repeated once more, okay, for the next time step. Okay, and let's say here and repeat. Okay, I hope that's clear. That's what they mean by coupling. Okay, you have two simulators. They can be from different software, different company, but that's actually what it means. I go check the rates. I can maybe produce the target rate. If not, I calculate new rates, and then from there I compute. Assuming these rates can be produced, I compute the next time. Okay. Okay, and there are other, so I think in the compendium we have a section if you want to read more in detail, and I think I gave some references for those of you who are interested in coupling. It's just at the beginning. Okay, I call it material balance because that's really what you use: the saturations, pressures, then you compute the well IPR, run the model, you find the results, you transfer, then you see how much I produce, and then you solve again the equation. Okay? If it's a reservoir simulator, it's slightly different. Okay? In this case, the reservoir simulator is computing the IPRs. Yeah. Let me copy this. So on page page 19. Okay. What does it mean to make it implicit? So that is explicit because I don't redo, let's say in T2, okay, I'm assuming the rate remains constant for this step, okay, from T1 to T2. It's like this rectangular approximation, right, for the Q, for the cumulative rate. But it might be that at this time, that rate is not feasible, okay, that rate that I have imposed. And then I have to find a rate for time 1 and a rate for time 2, and the QP, how much I produce, is simply, I can make a trapezoidal integration, right? But for that I have to redo the step. For that I have to redo T1 and T2. So I leave it to you to think about it. Okay, there are many papers describing that, but just keep that in mind. I can also have implicit coupling. Okay, and there are different methods to do implicit coupling. Requires either, so some approaches people have done to make implicit coupling, solving all equations simultaneously. I think maybe I have an example. Okay, so you have to make a system of equations that you include also, in this case, these authors, they have a reservoir simulator, and they included in this reservoir simulator the network equations. Okay, so if you see here at the end, they're giving an example of the matrix system, okay, where part of it are the reservoir equations, okay, and part of it are the network equations. Okay, so you try to solve everything at the same time, which might not be suitable if, for example, you have the two models are from different companies. Okay, they usually don't give you access to the equations, they don't give you access to the source code, so you cannot make that integration. Okay, so in that case you have to do it manually, and then it takes more time. Okay, so basically solving all equations simultaneously. Also, you can rerun the step until some convergence is achieved. Okay, for example, you estimate rate, then you calculate the next step, you see how different the rates are, they are very different, then you redo the step until the rate is exactly the same. Okay, so you have some tolerance how many times you need to redo the step.